5.3 voltages in series circuit. So here, from previous session, we know when the series resistors connect to a source Vs, the current is uniform. The current is same at any point of the circuit. How about now, let's take a look at the voltage drops on every resistor. For example, if you want to measure the voltage drop on R1, let's call this voltage V1, and then this voltage is between the left and the right points of R1. The question is, what is it? From Ohm's law, we know voltage equals to current times resistance. The current at here, anywhere in the circuit, is I. The resistance is R1, so V1 equals to I times R1. How about the voltage drop on R2? Let's call it V2. We apply Ohm's law again. The voltage drops here is the current I times R2. The current is still the same because, again, it's in series circuit. Current is same at anywhere along the circuit. How about the voltage drop on R3, V3? That equals to I times R3. And how about the voltage drops on the last resistor, Rn, called Vn? This equals to I times Rn. So let's see how to apply this concept to find the voltage drop on a resistor. For example, let's look at this circuit. The circuit has three resistors, R1, R2, R3. They connected in series. And there is one voltage source, Vs, equal to 12 volt. We want to know the voltage drop on every resistor. Let's find the V1 first. V1 equals to the current times R1. Since we know the current is 1.2 milliamps, it multiplied the resistance 1.0 kilo ohm. The product is the voltage V1. After multiplying 1.2 milliamps, which is 1.2 times 10 to the power negative 3 amp, multiply 1.0 times 10 to the power 3 ohm, that 1 kilo ohm, the product is 1.2 volt. Similarly, for V2, that is current times R2. Substitute the variables by the numbers, 1.2 milliamps times 3 kilo ohm. So the milli and the kilo, they cancel out because milli is 10 to the power negative 3 and the kilo is 10 to the power positive 3. They multiply to each other is 1. So we can simply multiply the 1.2 to the 3 is 3.6 volt. For V3, that is current I times resistance R3. Similarly, it's 1.2 milliamps times 6.0 kilo ohm. The product is 7.2 volt.